Good afternoon. Today's topic is about the pain, its recognition, prevention, and alleviation in laboratory animals. Uh, this is a central topic of the laboratory animal science because the experimental procedure and the samplings may cause discomfort and even pain to the laboratory animals. Therefore, this is our obligation to prevent and alleviate it by using analgesia and anesthesia. But to be able to evaluate the severity of the pain, and we have to know about the basics and the signs and the different scoring systems. The study plan for today will be the pain feeling and all the others. Introduction, definition of the pain, diagram of painful effect, physiology of pain, principle of homeostatic mechanism, nociceptive glioneural complex, and the enteric glia cells as a new play roller in this complex phenomenon. Parameters to measure the pain, for example, sonogram of a hungry chick, functional nuclear magnetic resonance imaging, behavior analysis, blood component, etc. Rat trials of Weiss about the predictability and controllability of pain and the change of the perception by that way, and the possible and partly explanation of this phenomenon by the so-called corticothalamic blunting, and finally applied topics and regulation. Before all the scientific things, I will give an illustration of the so-called analogy principle. And why? Because if all the scientific evaluation could not give a final decision about the pain feeling or the level of the pain of the animals, we have to use the analogy principles. It means that we have to think that you are in the place of the animal and would you feel a pain or not. What is the pain? The pain is a special form of stress. We have talked about a scale that we have the welfare, we have the EU stress, we have the distress, we have the discomfort, and we have a pain. So this is a scale. About the stress we will speak later on, but today we see the pain. The pain is a distressing feeling, often caused by intense or damaging stimuli. This is unpleasant, sensory and emotional experience associated with actual and potential tissue damage or described in terms of such damage, if you are speaking about human, who can give a report about his pain feeling. In medical diagnosis, pain is regarded as a symptom of an underlying condition, as a very important, more or less, but aspecific symptom. Maybe the localization is not aspecific. And what is the nociceptive pain? The nociceptive pain is caused by stimulation of sensory nerve fibers that respond to stimuli. The most common categories are thermal, for example, heat or cold; mechanical, for example, crushing, tearing, shearing, etc. of the tissues, and chemical, for example, iodine in a cut or chemicals released during inflammation. Some nociceptors respond to more than one of these modalities. They are the polymodal nociceptors. For example, on the mouth and lips of the fish, it is very typical, the polymodal nociceptors. The density of nociceptors in the different tissues are very, very different. And this will cause that some tissues has a very high sensitivity and another less. We have also a sexual dimorphism in this density, namely the females has a higher density of nociceptors in the tissues, therefore their sensitivity is higher, but at the same time the pain feeling, beside this pain feeling, the resistance is also higher. To see the tissues, everybody knows that dental pulp is very sensitive. Who once in his or her life visited a dentist. But the cornea is also very sensitive, and you can use the cornea reflex. At the end of an experiment, when we have to make a euthanasia of the animals, we have to be sure that the animals are really dead. And for that, you simply have to touch the cornea, and you can, if no movement, you can be sure that this is really a dead, really a cadaver. Testis. If you have seen a soccer match and you see that during a free kick, the members of the wall will protest not their cornea but their testes. Okay, the next in decreasing order, nerves, spinal cord, and skin. The serous membranes, periosteum, and vessels are of medium density and sensitivity. Viscera, the lower level than the previous. Therefore, it is possible to make operation in a local anesthesia of a liver or gut operation. Joints and bone are less, and the brain. In the brain, there are no nociceptors at all. And how can we have a headache? Well, the Mennings may have nociceptors, so this is one of the sources of the headache, and the second, of course, the vessels of the brain. Can you see that some migraine bound? Now we see the official definition of the pain according to the International Association for the Study of Pain, 1979. This is an unpleasant sensor and emotional experience accompanying an actual or potential tissue damage. In my mind, it is not totally true because simply emotions may cause pain in some cases. And the lower level of the pain, everybody knows that basically the pain has a physiological role. It is the so-called the watchdog of the organism, like Hippocrates has wrote more than 2000 years ago. But it is not clear in each cases, but for the discomfort, it's absolutely clear. This is a special, hardly definable form of pain, which can be considered as an adaptive biological function, warning the living being to the damage of the part or to a potential danger. Can you imagine that an animal has some arthritis or some wound on the leg, and by the laming, by discomfort, will have a changed gait, and in this way will release the damaged part. Presence of pain in animals, how you can see and evaluate the presence of pain in animals, unfortunately, many times cannot be known for certain. Why? Because we cannot ask the animal about the pain feeling. But it can be inferred through physical and behavioral reactions, and also of pathophysiological changes in the blood and other tissues. All vertebrates can feel pain, and that certain invertebrates, like the octopus, may also. At the end of this lecture, we will see this analysis in detail. To see that the animal have pain or not, we have to see closer the attacking points of painful effect, of painful stimuli on the animal. You see that it can be on the emotions, on the physiology, and on the behavior of the animals. But if we see it closer, we will see that an aversive sensory experience like pain can be caused by actual and potential injury, and this will elicit protective motor and vegetative reactions, which will cause a change in the behavior, will result in physiological and emotional changes, learned avoidance, and all of this by one and summarized may modify species-specific behavior, including social one. So it is important that the animal are alone or in a social group. Only one example. Rats were trained to take, by pushing a pedal, some anesthetic pills. Yes, and they made a operation, and they followed the post-operative phase. If the rats were housed individually, they use the pedal more frequently, and they have ingested more anesthetic pills. If they were in group, in a social group, which is normal for most of the rodents, with the exception of the golden hamster, of course. I hope that everybody told in itself, muttered in itself, that hamster. Okay, so this is the releasing effect of the social environment. We have to see the criteria to feel pain. Which type of animal can feel pain? Because it is not. It requires some development of the nervous system. We summarized in 7 points. Has a suitable nervous system and sensory receptors. This is the physical prerequisite. Physiological changes should occur to noxious stimuli, displays protective motor reactions, should have opioid receptors, and should show reduced responses to noxious stimuli when given analgesics and local anesthetics. Should demonstrate a trade-offs between stimulus avoidance and other motivational requirements. Only and as an example, we have transgenic mice strains which has a inherited arthritis, and they are living in a continuous pain. There is a trade-off if they are going to eat. They make a evaluation that the thirst and the hunger cause a higher level of pain, or the moving. Shows avoidance learning by means of the associated learning, and the real pain feeling can be found only if there is a high cognitive ability and sentience present. A short review of the physiology, repetition of the physiology of the pain. We have the nociceptors, delta and C afferent ends. We have very important opioid peptides in the brain and in the spinal cord and in the end points of the nerves, like encephalin, pro-opioimmelanocortin peptides, or endorphins and dynorphins. For more details, see Pain and Mechanisms of Analgesia, Sigma RBI 2002. It seems to be old but excellent description. Now we have to see closer the reflex response to painful stimuli. You can see on the picture that nociception involves the transmission of a signal along nerve fibers from the site of a noxious stimulus at the periphery to the spinal cord. The signal is also transmitted on the brain, but at the same time a reflex response such as flinching or withdrawal of a limb is produced by return signals originated in the spinal cord. The pain signals route is different. The pain signal may travel from the periphery to the spinal cord along an A delta or a C fiber, and the speed will be highly different. Since the A delta fiber is thicker than the C fiber and is thinly sheeted in an electrically insulating material, the myelin, it carries its signal faster, 5 to 30 meter per second. This is the so-called saltatoric, from runway to runway shrinkage. This is the so-called saltatoric way of pain signal traveling. And if the signal is traveling through the unmyelinated C fiber, the speed is only 0.5 to 2 meter per second. Pain evoked by the A delta fiber is described as sharp and is felt first. If you touch a hot plate, you will, of course, by the previously described reflex, take your hand off, but at the same time you will feel sharp pain. This is followed by a duller pain, often described as burning, carried by the C fiber, and this can last many hours or even more. Here on this excellent picture you can see a nice picture how if a nail is put in the tissues, how can the stimulus go to the horn of the spinal cord. And this is a new discovery that we have not a simple free nerve ends as a nociceptors below the skin. There is a so-called nociceptive glioneural complex. In the middle of this picture you can see a cell, this glia cell, which is the conjunctive cell, conjunctive tissue of the nervous system. But this is not independent, isolated cells, because we can see on these pictures that the cutaneous Sven cells from a glioneural end organ in the skin. You can see that at the left one cutaneous Sven cells, but on the right side and in the middle you can see that they are making a net in the organism, and this can be considered as an individual organ according to the new approaches. And also a new play roller in this drama is the enteric glia cells, which are in the wall of the gastrointestinal tract. It is a new player in the abdominal pain. Enteric glia cells are in interaction with the immune cells, and they can also modulate the pain by the primary afferent neuron. A little bit more, you can see on this picture that the enteric glia cells will release pro-inflammatory mediator substances, will regulate of immune cells, and will activate elements of inflammation. We have also the satellite glia cells, also releasing pro-inflammatory cytokines and contribute to the sensitization of dorsal root ganglia. And the absorbed substances and via the nerves, this is a stress for the central nervous system, where the other glia, the astrocytes and microglia, are contributing by active. They are active during inflammation and nerve injury, and they also are producing pro-inflammatory mediators and contribute to glutamate excitotoxicity. Yes, and the opposite is also true, that stress will influence the brain, and the nervus vagus will influence the enteric glia cells, and the pain, the abdominal pain, remain. And another player is the microbiome. So you see that now the whole picture, that microbiome, the composition of the flora and fauna in the gut content, the stress, the inflammation, and the neurotransmitters are the players who are controlling the mast cells and the histamine release, the macrophages, and the cytokine like tumor necrosis factor and interleukin 1 and 6. And all the two, the histamine and the cytokine, influence the primary afferent neuron, and it will cause the sensitization and or activation of nociceptors. So this will contribute to a higher level of pain, of course, and a long-lasting pain. And here you can really see that the A delta fiber is thicker and thinly sheeted than the C cells, as a take-home message from this small section, or the most important. One more important balance and control at the level of the spinal cord is the gate control theory of the pain, described first by Melczak and Wall. Melczak, excuse me, the Hungarian H, and Wall. It means that harmless skin stimuli through the A beta fibers inhibit the transfer of painful stimuli in dorsal horn, and interneurons of the dorsal horns are the so-called gate for the stimulus. And if there is a predominance of painful stimuli through the A delta, through the mentioned A delta and C fibers, this may open the gate. This is the so-called threshold of the pain feeling. Feeling or awareness of the pain. The nerve impulses from nociceptors may reach the brain, of course, but where the information about this stimulus, that what is the quality, where is the location, and how is the intensity level in some some spots of the brain, and another spots, the affectivity, the unpleasantness, the emotions, the affective part are registered. And here you see a summarizing slide. The right side, you can see functional magnetic resonance imaging, brain scanning, which has been used to measure pain and correlate it with self-reported pain. Of course, this was in human study. And on the left side, you can see the description, what can be seen on the right side. This is the pain matrix. Pain matrix, like the movie film, a matrix. The intensity of pain awareness is influenced by higher neural levels. So the brain contributes to the formation of the pain feeling. Pain-related activity in the thalamus spreads to the insular cortex, which in turn will distinguish pain from other homeostatic emotions such as itch and nausea, and anterior, and also from the thalamus, not only into the insular cortex but also in the anterior cingulate cortex, the affective motivational element, the pleasantness or unpleasantness, of course pleasantness only in some people, unpleasantness of pain. Pain that is distinctly located also activates primary and secondary somatosensory cortex, which will give the quality of the pain feeling, whether it was a burning or a cool. And the tragic and shocking example will be given, that really the pain feeling, the quality and the objective part of the pain feeling, and the affective emotional part is in different, they are in different spots of the brain, and by a training of many uh, uh, decades of meditation, Thich Quang Duc was able to control the pain feeling and can make this self-immolation in 1963 in Saigon against the Vietnam War and against the Vietnam government to that day's Vietnam. So this is a very sorry picture, but I had to show you. And this picture shows the rat trials of Weiss about the predictability and controllability. You can see the experimental design. There is a light source, there is a electric shock generator, and the tail of the rats are fixed, and also there is a wheel in the second series of trials. And here you see this rat trial of Weiss about the predictability and controllability. Rat 1, 2, and 3 and rat 0, 1, 2, and 3 are not single rats. Some people wrote in the exam, but they are groups. So rat 1, the light was presented at certain intervals, which was followed by an electric shock to the tail after exactly 10 seconds. Rat 2, the same number of signals and shocks were also presented, but without a clear relationship between the signals and the adverse shock. Rat 3, control. Rat 01 could switch off the shock by turning the wheel. Rat 02 also had the wheel, but one which was not connected to the shock generator. At the end of the experiment that compared the animal's physiology, pathophysiology, blood composition, and finally the necroscopy and the histopathology, it turns out that the rat 1 and rat 01 had as good as the control values. So despite of the pain, because in the rat 1 group it was predictable, and in the rat 01 it was predictable and it was controllable, we can make the conclusion that the predictability and controllability may decrease the pain feeling. Later on we will see the explanation for that, but before that we have to see short that we have also maladaptive pain feeling, which have lost the original signal function. It may be the spontaneous if no nociceptive stimulus occur, we call allodynia and hyperalgesia. And there is also a possibility when damage, disease, and inflammation will produce regulatory molecules, excuse for the typing error, at the neurons receptors. This is the neuropathic pain. The most important example in the small animal practice is the polyneuropathy in case of diabetes of dogs and cats. And here is the explanation of the reduced pain feeling by the controllability and uh, predictability, as well as the high emotional state. This is the corticothalamic blunting or central top-down pain feeling modulation, namely from the brain stem, exactly from the PEG, periaqueductal gray, descending system ends in rexid laminae, and opioid peptides will be released on the receptors. And this is in excited emotional states may occur that even a severe tissue damage remain unconscious due to the general analgesic effect of secreted opioid peptides endorphins. This is the so-called stress analgesia in the medical slang. Here you can see Amr bin Navid, the father-in-law in Muhammad in a battle, that his leg was cut, but owing this corticothalamic blunting, he was able to take his own leg and continue the fight. The main pain sources are in the laboratory animal science, the hunger and thirst. Here you can see hours without food, and the upside you see the time of the gawking. These are the sonogram of the very hungry chicken. And here you see a giardia. Giardia is very important intestinal parasites for the animals, sucking nutrients and the brush border. You can see this camels in a heat. Heat is also microclimate. You see a old-fashioned horse slaughterhouse. Below you see all the surgical procedures, and right side to have some connection to the animal nutrition and dietetics. You see allergy, a food allergy in a cat, which is so painful that it's going to self-mutilation. Now we will see the evaluation of pain and discomfort. It will be difficult, the extrapolation from human, because or from species to species. The species differences are great. The apes are so smart, like rodents thinker, but the other animals' signals are not clear for us. So based on the analogy, it's difficult. We will mostly use the scientific trios, basis of tissue sensibility, behavior, physiology, and necropsy, the previously known tissue sensibility, and the trio of behavior, physiology, and necropsy. But before that, I show some nice pictures to the analogy. Renoir, motherhood in orangutan and human, or the cry from Munch, and how the orangutan baby was taken off from her mother. So the trios parameters of evaluation are the behavior, the physiology, and the pathology. In the behavior, if you see stereotypic behavior, aggression or apathy, you can conclude, you can think about pain feeling, or at least discomfort. In the physiology, the decrease of the body weight, the increase of the heart rate and the blood pressure, the increase of the concentration of stress hormones and opiates in the blood, decreased immune response, suppressed reproductive functions, and shortened lifespans are the physiological signs of the pain and uh, long-lasting pain. And in the pathology, also you can check the weight losses, the skin and the hair coat state. It can see that it's shriveled and the lack of grooming. You can see muscle fat ratio changes, less fat, of course, depletion of the fat, electrolyte balance, dehydration, by picking the skin or by making the needle test on the skin, you can check the dehydration. Measure of lymphoid organs related to uh, not not the objective number, but related to the body weight, or in the toxicology to the brain weight. Sign of infections like bleeding everywhere, or increase of the spleen, adrenal gland weight and cortex will also larger. Here you see only for a minute, because during the plenary practicals I've shown you the body condition scoring of the mouse. Of course, that BC1 and 2 emaciation are signs of long-lasting pain. And here you can see a scoring system to evaluate pain and discomfort after Morton and Griffiths. And the scoring system gives mild, moderate, or substantial classes. And in the mild, one have to give score 1, in moderate 2, and in substantial 3 or 5. I don't have time to analyze in details, but please read it thoroughly through, because all the items are important. And here is the key to the scoring system. We have 7 groups of symptoms of the previous table to evaluate. We have to classify the symptoms in the appearance, water feed intake, behavior, pulse, cardiovascular system, digestive system like diarrhea or not, and nervous system. And 0 point no pathological symptoms, as I've told you. 1 for mild, 2 for medium, and 3 or 4 severe pain. And the summarized score evaluation shows us that above 10, 10 points, the pain is undoubtedly should be moderate, possibly termination of trial. And above 20, pain must be alleviated, obligatory. The experiment should be finished, because the animal's biological answer cannot be considered as physiological. Many times in this case, we have to make euthanasia. Illustration to the behavior analysis. For example, in rabbit, the relaxed and the anxious body can be really evaluated. The relaxed can make a differential diagnosis from the narasin intoxication, where you have also a flexed paralysis of the hind legs. And we arrived to the dolorimetry, which was in detail seen during the practicals, so I will only give a short overview. The dolorimetry is a measurement of the pain response. Pain measurement techniques include the paw pressure test, the tail flick test, hot plate test, and grimace scale. And the grimace scale received his front page from this lady who received first during the Second World War injection. But we see the grimace scale or score is working with facial. This is all repetition recalling from the plenary practical. Grimace scale is using facial action unit, and the facial action units can be seen on these pictures, are illustrated, and the mouse grimace scale consists of 5 facial action unit, and here you see that perceiving of suffering by the facial expression of pain in the mouse, and you can see the eyes, the nose, the cheek, and the ears. And as an extra, the fifth would be the whiskers. In case of the red grimace score, the nose and the cheek are flattening instead of the mouse type of behavior. And you see in case of the rabbit, the difference is to the rat that the ear position is excluded from the analysis. In case of the dogs, we use the analog scale, which is a minimum value of 0, no pain, and 100, which is the worst possible pain. For mini and micro pigs, you have on this picture, I try to emphasize that mini pig in the middle, that the mini pig has to receive obligatory environmental enrichment. What about the case of the horse? In the horse, we have also a grimace scale which consists of 6 facial units. And here you can see the appropriate picture published in the +1 horse grimace pain scale. We have to modify this grimace scale according to the previously shown density of nociceptors in the tissues, which tissue are in the question. We have also aid, the animal needs index, which is used, can be used as a simplified method for dog, pig, goat, and production animals. The pain in the lower animals can be evaluated by the so-called meta-analysis, which is a new and important tool of the third R, the refinement. And here you see that in the introduction shown criteria for pain feeling are on the left side, and we collect 50 to 100 related scientific publications, and to the items that earthworm, insect, cephalopod, fish, herbs, bird, mammals, we will put a plus if they have this criteria, minus if they have not, according to the majority of the journals, and the question mark if there are a discussion. Based on this analysis, the 63 Pro 2010 EU directive included not only the vertebrates but also the cephalopods in this protection of animals in teaching and experiment. This directive gives also the pain categories: no pain, which is less than an injection. We have the mild, the moderate, and substantial or severe pain, and with anesthesia and oversleeping. There is no pain legally, the organ collection, which is 1/3 of all the experimental animals. But this is a pain breeding of transgenic animals with painful phenotypes, for example, arthritis or diabetes or so. In this case, even the breeding, for the breeding, you have to ask for permission. And the take-home message is the physiological basics of pain feeling, gait control theory, definition of pain and distress and discomfort, reflex response to painful stimuli, Weiss rat trial about the predictability and controllability, corticothalamic blunting, endorphins, sources of painful stimuli, evaluation of pain, analogy, behavior, physiology, nociceptor, density, and necropsy, grimace scale or score. Please don't confuse with the Morton scale, and the pain categories legally. And thank you very much for your attention. If you have questions, you can write me email or can you call me on. And if not, in a week we will continue with the circadian rhythm. Take care of yourself and remain healthy and happy. Thanks.